Welcome to today's demo from Introspect Technology. We're here today to talk about receiver testing for PCI Express devices. This is a requirement that has emerged in Gen 2 applications and also in Gen 3, where receivers are required to be stressed with jitter or voltage stress so as to to understand their maximum sensitivity to disturbances on received data. So receiver tolerance testing is a big industry topic, and we cover it here with the Introspect SV1C SerDes tester. So the tester itself is shown on the right-hand side capture here, where my mouse is pointing. And as always, we're connecting multiple channels simultaneously to the device under test. So 8 pattern generators are going to the receivers of the device under test, and 8 pattern detectors are listening to the transmitters of the device under test. And to perform receiver jitter tolerance testing, we've written scripts that are available for our users. And we are able to enable the script with simply toggling this command here, the jitter tolerance test, toggling it from false to true. And so in our current setup, we will be performing the device identification test as per this entry here. And then we're performing the jitter tolerance test as per this parameter as well. So we'll go ahead and click run and see what happens with the device. So as always, we perform the device identification just to make sure that all lanes are connected and that they're able to enter into loopback. One of the best things about PCI Express protocol is that receiver testing can occur through a loopback connection. So stress happens on the receiver port of the device, and then the device error checkers are checked through the loopback connection back to the tester. So the device has been identified, all 8 lanes are connected and are able to enter into loopback. Now we're doing the jitter tolerance test, so we train the device into loopback. We apply a specific loopback test pattern that's really up to the user, and so we've selected a long 8-bit, 10-bit encoded pattern. And now we're sweeping through the jitter tolerance curve. So for each SJ frequency, we're sweeping jitter amplitude into the receiver to identify its failing point. So in each iteration of the loop, the SV1C increments its amplitude until we reach a failure point for the device. And so you could see that the number of iterations really varies depending on the frequency and where the device has failed. So here we go, the test has already ended and we performed the receiver jitter tolerance test, and if we double click on the output icon here, we basically show that we have performed the complete characterization of the SJ jitter tolerance graph on the device. And the device is able to tolerate about a half UI of jitter across all frequencies, which is consistent with what is expected from a device of this class. Thank you.